Hi, I'm Nick from the channel AutoTechNick. I'm a Ferrari Master Technician, a WyoTech graduate, and today I'm going to spend a little bit of time walking you through the steps it takes to properly seal up a valve cover gasket on this F355. On one valve cover, counting the seals for the camshafts, I believe we have 14 gaskets to consider to seal up one valve cover and two cams. I think the reasoning behind all of these gaskets kind of comes down to machining and how Ferrari chose the machine, the cylinder head. If we could just have, you see the one paper gasket as a perimeter, we can't have that because they had to bore the cylinder head for the camshaft to receive the camshaft, and so these areas have to be open, and it's just kind of the method that Ferrari chose to fix that problem via machining. So I think it's a byproduct of manufacturing. They certainly didn't design the engine to have so many gaskets. I think it was their solution to the problem. It wasn't up until about 2005 when they went away from this style of sealing up the engines into a more conventional rubber gasket. But up until that point, probably on the V8s from the late 70s all the way up to 2005 is pretty much the same way, and it's pretty much the same for all the V12s, about the same configuration. Yeah, so this one back here, they come in one piece and as one gasket that's made, and I think most people would view that as a normal valve cover gasket because most traditional valve cover gaskets just run around a perimeter of the cylinder head. And that's where I was saying on these gaskets, these sections have to be open because that's where the machining was done for the camshafts. So these gaskets are actually meant to be torn, broken, or cut in these sections. And eventually, to install this on the engine, I'm going to take the one-piece gasket and break it down into 4 pieces. So I'm going to keep the 2 long outer rails and just these small squares here. So all 4 of these sections will be discarded and are not needed. Getting this gasket brand new like this looks like it's broken, but it's actually not, because I'll be making the same cut in all those pieces eventually. So as long as it's not torn in this section, we're good. So I got it all laid out here. Essentially, this is how it's all going to sit in the car. And these are the rear gaskets, and there is a plate like so where this O-ring goes on. Now it's different on the back side because on either side of the engine there's either going to be a housing and a camshaft sensor, or on bank 2 or the driver's side of the engine there's going to be a vacuum pump. So it requires a different paper gasket, and this gasket basically overlaps halfway on the cylinder head, halfway on the valve cover to seal up that end gap. But on the front of the engine there's some aluminum plates, and these O-rings seal the outside of the aluminum plates, and the cam seals go on the front and seal the cam seal to the aluminum plate. And those are essentially what are overcoming the half moon or the circular holes that were used to bore the camshaft into the cylinder head. We have our valve cover gasket that goes around the perimeter, so the top and bottom rails are pretty simple. These small little sections sit in the middle, and those are tricky to get in there and seal up. And we have very, very small fine O-rings that go in the center, and those seal up the tubes where we get access to the spark plugs. So in all, by the time we break this one gasket in the 4, that gives us our 14 gaskets. So let's head over to the engine and I'll show you how this all works and looks once it's fully installed. So we have the valve cover off on this side, and this one actually worked out to be one of the best examples I've come across where all of my gaskets stayed on the cylinder head. They actually exhibit all the problems that are very common, which I'm going to show you some tricks to prevent, but it gives a really good outline of how the gaskets are positioned and really how they interact with one another to seal the engine up. Now it's a bit more clear. You can see that we have our camshaft caps and our camshaft here. And the reason why this main paper gasket's broken into 4 pieces is because when they're manufacturing the head and they're boring out the camshaft, they need access to get through there, and that gasket would intersect right in the middle of that. So their solution to overcome that is they have these removable aluminum plates at the front of the cylinder head. They're bolted on down here at the bottom, and that's where we have those green O-rings, which were set up on the bench. And we also have our cam seals on the front side. So these will slide off the front of the camshaft, and I replace those gaskets separately. But one of the big problem areas is where our paper gasket up here in the corner intersects with this rubber O-ring. You can see the remnants of a lot of white sealant here, which is typical and standard when you're sealing these up. But we have 2 gaskets. We have a joint. They're not firmly connected to one another, and that causes a lot of problem areas for multiple reasons. One, it's not one continuous gasket, so it's hard to make them seal up. And secondly, which this car is the prime example, if we dart back here at the back corner, you'll be able to carefully notice how this gasket has slid out and away from its black rubber seal. You can see that it's no longer butted up on that rubber O-ring, and it has slid all the way out and down. And if this was one continuous gasket, it would be connected to the gasket material up top here, which would prevent that from sliding out. It also doesn't help that our stud that's nearest this location is about an inch away, so there's really nothing other than the clamping pressure of the valve cover keeping this gasket in place. You can see that it's just a simple plate back here with a plug, but we still have the same problem with all of the junctions. And up top on this side, it's a bit different, where we use that 3-point paper gasket that bolts on the back side and has a cover for the camshaft sensor, and it bolts on 50% on the cylinder head and 50% on the cam cover. So then there is actually another junction there where this gasket tees into the other paper gasket at 90 degrees. So these are all leak points. I have a leak point where those two gaskets meet. There's a leak point right here again. Yet again, another leak point where the rubber O-ring intersects with this paper gasket. We can see where this one has completely failed and slid out, and that was actually physically leaking on this car. And you notice it drips oil right onto your exhaust. So another awkward part of this is the front gasket. Once we break the paper apart, this is all that's left of that center section, and it just sits in between our two cam plates and is sealed tight or held in position with just one mounting bolt. And this gasket is preventing oil from leaking, straight forward from the cam cover, but also has to worry about this junction, and there's just not a lot of material there to hold it in place. It's essentially just kind of wedged. And that's one reason why there's silicone there, because all of these junction points in the corners, we do seal up with a little bit of silicone. However, that can pose more problems, just like on this back side, because if you put too much silicone up here in these gaps, as you tighten down the valve cover, that silicone will actually hydraulically push that gasket out and down. And then if that happens, you're essentially pulling the cam cover all the way back off and replacing the gaskets. However, that can get more complicated, because a lot of times when you pull the cam cover off the engine, these rubber O-rings right here can get stuck into the cam cover and they can tear. If this O-ring tears, the only way to replace this O-ring is to remove the timing belts, remove the cam gears, and remove this plate. Meaning if you do a repair as simple as removing the valve cover gasket from this car and you tear this O-ring, you're doing a timing belt job. So having this tear can be quite catastrophic to your job, and having a gasket push out can be quite catastrophic as well. There's been many times where we'll finish a car, be sure this gasket doesn't push out. As soon as you fire the car up and get some temperature built into the engine, this gasket pushes and slides out, which is devastating because you have to redo your valve cover gasket. But in the process, you tear that gasket, where you essentially lost all of your work during your timing belt job. Now I'm going to take you guys to the bench and show you a couple things that we can do to the valve cover to prevent these leaks and the gaskets pushing out. So with the valve cover over here on the bench, there's a couple more things that we can talk about. Now, one thing we need to talk about is this back cam plate or plug. And if you look carefully on this cam plate, you can see that this O-ring that was in there has a very large gouge and section missing out of it. That should not be that way, but that is normal, as in it frequently happens during assembly of the car. Now, this is obviously another very big leak point because it's right at the junction of where the cam cover meets the cylinder head. So this tear in this gasket actually occurs back here from this back corner on the cam cover. The hole that's machined to this is dead center on the center line of the hole, so that's almost a 90-degree edge right there where this sits in, like so when you're assembling it. And it's the same thing on the cylinder head. And we have a very sharp, tight corner right there, and it's a very tight tolerance. So even if we lubricate the new gasket or put silicone to help everything assemble and slide together, as you tighten the cam cover down to the cylinder head, those sharp corners actually dig into this O-ring and pinch that O-ring right there. And then that's just opening up the opportunity for having oil leaks. One of the tricks that I do to prevent this is I'll take a very small file and I take just the slightest amount off of it right around that corner. And my goal is not to remove a bunch of material. I want to remove the sharpness and harshness of that edge, so that way it doesn't have anything to bite into and grab this gasket. So then when I assemble it, it slides over it and into position. It doesn't grab it and pinch it. Before we go and reinstall the valve cover, I actually need to address everywhere where there's one of those gaskets, and I also need to do it at the front junctions on all of the locations where it had the green gasket on the front of the cam plate. Now, to address the issue with the valve covers that's pushing out or sliding out, I take a automatic punch and I will make some marks and make usually 3 marks right up here on the rail, right on the end. And I'm just gonna press this punch down, make a divot, believe it or not, in the surface of the valve cover. And it's not so much the divot that I'm looking for. When I use this punch and it punches the material, it's gonna make a low point and push the material, but it pushes the surrounding material up and makes a high point. So it's almost like it's knurling the surface. I do that on all 4 corners of the valve cover. I also do all 4 corners of the cylinder head. I do so when I put the valve cover on, it has more than clamping pressure to hold that gasket in place. It actually has a little bit of bite that can press into the surface of the gasket and prevents it from sliding out. Now, a lot of people would just think that they're gonna take all these surfaces and cover them in a really aggressive sealant or silicone to prevent this from happening or prevent the gaskets from leaking. And that is not typically how it's done. And the reason why I would say is it's probably courtesy for the next guy. Because these cars need timing belts every 3 years and the engine comes out, very few people do that because the amount of time it takes to clean all that sealant off of the valve cover, it really adds a lot of work for the next guy. And I feel it's just kind of an unspoken rule. Think about the next guy and pay it forward on how you seal the valve covers up. So that way when he's servicing the car, it's gonna be easier for him to get the gaskets off, everything cleaned up and prepped upon reassembly. So you can see there's a couple different things we have to keep in mind and consider when putting a valve cover on this car, so that way we don't have a gasket push out, we don't pinch an O-ring. And really all of this is done to prevent any future oil leaks coming out of the engine, especially with the exhaust in such close proximity. For a rough example, if this had a traditional valve cover gasket, which is just a rubber gasket around the perimeter with some rubber grommets on the bolts, it probably would take one person a matter of 5-10 minutes to put a valve cover gasket on and be done with the job. In order for me to clean up all the gasket and silicone on these, file down all my edges, stake the edges of my gasket rails, and get these fully assembled so that way I don't push out a gasket and I don't have to worry about one pushing out. It's quite a bit of a process, and it usually takes me probably in the neighborhood of an hour, hour and a half per valve cover just to get them on, sealed up, and ensure that I don't have any problems down the road. If you guys like this video, be sure to like and subscribe to the WyoTech channel. If you want to see more behind the scenes content, you'll see me over on AutoTechNick.